Hello everyone, welcome to Dakshin Academy. Today let us discuss methods of design. We know that there are three main methods of design in RCC. One is working stress method and ultimate load method, and third is limit state design. So in today's class let us discuss in detail about working stress method and limit state design. So before this we have to know what is meant by design. So design is nothing but for a given load and material. For a given load and material, what are the dimensions required? Finding out these dimensions required, that is design. So the method we deploy here for a given load and material, we use different methods to find out the dimension. This is design. So and then let us see what is working stress method. Working stress method, one thing main important thing about working stress method is it considers the relationship between stress and strain to be linear. Means it is considering only elastic region of the material, and it is completely ignoring the plastic region capacity of the material. What does this mean? Like we all know about Hooke's law. Hooke's law is for a Hooke's law means within elastic limit proportionality in precise proportionality limit, stress is directly proportional to strain. But if we see for concrete, like the relationship between stress strain curve is like this. So there is no linear portion here. But in working stress method, it considers stress strain relationship to be linear in both concrete and steel. And that is the first one. And second thing is, like as I mentioned earlier, like strength is considered only in the elastic region, and we cannot utilize the load carrying capacity in the plastic zone, because like we know, if it is the stress strain curve of the steel, like if it is the curve, so up to here it is elastic region. Elastic means what? Like if we remove the load acting on it, then the material regains its original shape after the removal of the load. That is elastic region. After this also, because due to reorientation of the or redistribution of the stresses, there will be plastic zone, which is completely ignored in working stress method. Because of this, what happens, like we are designing the sections for lower loads. Means as we are not using this part of the curve, so we are limiting ourselves up to here. So there is like the load that we calculated will be on the lower side. The load that the member will carry, the load that the member carries is on lower side. So because of this, what happens? We are designing uneconomical sections. And uneconomical sections means heavy sections with high dead load. So these are all like disadvantages using this working stress method. That's why like now we are using limit state method. So first thing is, in working stress method, stress strain relationship is linear in both concrete and steel, and we are considering the strength only in the elastic region. And the third important thing about working stress method is it focuses only on stresses and not on loads. So for example, like if we see that if in reinforced concrete, there are materials like, it is singly reinforced concrete, there are materials like concrete and steel. So these are the materials. And if it is the beam, these are the supports. Like if load is acting on the beam, it is W1, W2. Here it is material and it is load. In working stress method, if the load which we take into consideration is the actual working load or service load which is acting on the beam, we are not applying any partial factors of safety here. But in case of materials, we suppose for example, if M20 grade concrete is given, we apply like certain factor of safety here and we calculate the allowable stress. We calculate allowable stress in the material, both for steel and concrete, and we design our sections in a way that the stresses developed in the section are within this allowable limits. Okay, so we are taking the loads as it is in the working stress method, and for materials we are applying safety factors and we are calculating this allowable stress, and we are applying the loads so that the section does not exceed the permissible, the stress in the section does not exceed the permissible limits. This is about working stress method. And one more thing is like the failure load, as I mentioned earlier, the failure load which is calculated using working stress method is lesser than the experimental result. Why? Because we are considering only the elastic region strength, and we are completely ignoring this plastic portion from here. So the load which we calculate by using working stress method is lesser than the experimental result, because if we conduct any experiment, it takes into account the load carrying capacity of plastic region also. That's why the load calculated by working stress method is lesser than the experimental method. So what is the difference between this plastic and elastic material is like, if for example, let us see one example. If this is the beam and if we apply load on it, like if it is the neutral axis, if we apply load on it, like this is the stress distribution, and if we apply like stress gets developed in the extreme fibers, and if Fy is the yield stress, slowly the stress in the member, this beam develops, and at first it will be less than Fy, and after if we increase load further, stress F reaches Fy in the extreme fibers. So up to this it is elastic limit, and after this, even after this, if we apply load, then it will be like this interior layers, they also starts developing like yield stress. The stress within this fibers also becomes Fy. So not go beyond Fy, but this distribution takes place into the interior fibers. So from here it is like after elastic limit also there will be like redistribution of stresses and there will be load carrying capacity in the section. But working stress method will consider only up to this, and limit state method will consider beyond this also, until all the fibers reaches Fy. To that, state method considers the load. So that is one important thing. And one more important thing is like in working stress method, only this load calculation is considered at the time of construction, and it completely ignores the function of the building in service conditions. Like when the building is put into function, like many factors arises like cracks, deflection, the vibrations, and also we have after a particular point of time at constant loading deflection occurs, creep and shrinkage. All these things, like, we are not considering them in the design using working stress method. So this is also one of the biggest drawback in working stress. So in brief, working stress method is stress strain relationship is linear. Second one is only we are considering the load carrying capacity in the elastic region. So because of this, the load carrying capacity will be less than the experimental load, and we are designing, because of this we are designing uneconomical sections. And the most important thing is it focuses only on stresses, means it focuses only on materials, and it takes working load or service load as it is. And the last one is like serviceability criteria, like it is ignoring serviceability criteria when the building is put into about working stress method. And next is limit state method. So we know that in limit state method both ultimate load and durability can be considered. Means what? Like not only while designing, after that also, like serviceability conditions also we take into account. Okay, so in limit state we take creep, shrinkage, deflection, crack width. We check our design section for this serviceability conditions criteria. Second thing is we have seen earlier that working stress method we are taking partial factors of safety only for material, means we have to say that factor of safety for only for material. Here we are taking factor of safety both for material and loads. So we are calling it as partial, because partially we are applying it to material and partially we are applying it to load. So in limit state method we are applying partial factors of safety to both material and loads. So we know that if W is the load, we multiply it with some partial factor of safety here, and for design strengths also, if gamma is the FCK is the design strength. What are the things we consider later in next classes we will see about it. And main important thing is it is based on probabilistic approach. Means what? It is not a deterministic method like a working stress method. We consider like limit state is a state at which the design becomes unfit. Okay, just before the design section become unfit, up to that limit we consider the load. Just before this unfit means what we are doing, we are considering the section in plastic. Okay, instead of deterministic approach we are going for this probabilistic approach. Probability means there is a probability of failure at that point, and we are not like we cannot say it through experiment. Let us see one PYQ on this. And one more important thing is, in working stress method stress strain distribution is linear, but in limit state method stress strain distribution is parabolic and rectangle. We call it as rectangular parabolic. This is not actual stress strain curve, this is idealized stress strain curve. Idealized, because if we exactly draw the stress strain curve by actually like if we draw the actual values, it may be different from this, but we are idealizing that stress strain curve for concrete in limit state method is rectangular parabolic, and because of this we are considering this plastic zone also. So this is a PYQ once a gate question. Shape of idealized stress strain curve for concrete as per a limit state method, it is rectangular parabolic. In working stress method it is linear, but in limit state method it is rectangular parabolic. And what is the limit state? As we mentioned earlier, like the acceptable limit for safety and serviceability, we have to take this serviceability requirement also, like before failure occurs. This is the point of the failure. Just before that point of the failure, the acceptable limit of both safety and serviceability is called limit. Then we have two limit state. One is limit state of collapse and limit state of serviceability. As IS 456 mentions that why these two limit states, we design for this rupture. We design the section for this rupture, and this plastic instability occurs, buckling occurs. We take that all into account and we design the structure for limit state of collapse, and we check our design for this limit state of serviceability. As we mentioned earlier, limit state method not only takes into structure design of the section for safety or for at the time of construction, but also in the serviceability also it takes into account. But so for the serviceability we check our design. So this we have to remember, very important for competitive exams. What and all comes under limit state of collapse? Limit state of collapse, like wherever there is rupture, where there is buckling, there is overturning, all this comes under limit state of collapse. Bending, shear, torsion, compression. And limit state of serviceability, the things that occurs after once the building is put into use, that are limit state of serviceability. Deflection occurs after construction and after application of loads. Cracking also develops after construction. The building is in fire resistant. Everything comes when the building is in service. So we have to remember this. What is limit state? Limit state is acceptable limit of safety and serviceability before failure, that is limit state. Limit state, one thing we have to remember, that limit state is not the point where failure occurs. It is just before the point just before where the failure occurs. Okay, it is acceptable limit of safety. And in limit state of collapse it is like 4. Limit state of serviceability, it is deflection and fire resistance. That we have. So this is one PYQ based on the earlier slide. Which of the following is not a limit state of collapse? We know that shear, flexure and torsion, we design the section for this, so this comes under limit state of collapse. But cracking, this comes when the building is put into service, so this it is limit state of serviceability. The next topic is characteristic strength and characteristic load. So characteristic strength is the strength below which not more than 5% of the test results are expected to fall. What does that mean? If we test 100 samples, and if we say that M20 is the grade of the concrete from which these samples are made, like we can say that the characteristic strength is M20 only when 95%, at least 95% of the samples, means what? At least 95 samples has compressive strength more than 20 Newton per mm square, and only 5 samples have strength less than 20 Newton per mm square. Then only we can say that the characteristic strength of the batching which we take into consideration is M20. So it is for concrete, and for steel we assume that characteristic value is minimum yield stress and 0.2% proof stress. What is, like if we consider mild steel, the stress strain curve is like this. So minimum yield stress is here. So this will become our characteristic strength, characteristic value regarding stress. And if we consider high yield concrete, we do not have this exact break which we can recognize it as a minimum yield stress. So for this we consider 0.2% of proof stress as characteristic value. So 0.2% means 0.002, we take it as characteristic value. So this is what is meant by characteristic strength. And characteristic load means in 95% there is 95% of the probability that the load that comes on the structure not exceed this value. So 5% of the times it may exceed, but characteristic load we take it from IS 875. In last class we saw this code books, part 1, part 2, part 3, part 4. From this code books we take value like that value 95% of the there is 95% of the probability that will not get exceeded during the life of the structure. So next is like, let us see one PYQ related to this characteristic strength. Characteristic strength of concrete is defined as that compressive strength below which not more than 5% of the test results are expected to fall. And we have seen this in earlier slide. It's like IS 456 codal provision. And one more PYQ related to this characteristic strength is they gave 4 samples here. So we know that 150 mm cube is because as per IS 456 that concrete cube size for compressive strength determination is 15 centimeters, that is 150 mm. If they gave like 4 samples of 150 mm cubes of concrete, and this each and every sample gave compressive strength test results as 25 MPa, 28 MPa, 32 MPa and 31 MPa. So they asked for characteristic strength. When this type of problem, like for samples and their strengths, individual strengths are given, and if they ask us to find out this characteristic strength, we know this formula, Fm equal to Fck plus 1.65 times of sigma. Here they asked to find out Fck. So for finding out Fck, we have to first determine Fm and sigma. So Fm is mean average, like mean target average. Fm is average of the compressive strengths of samples given. So 25 plus 28 plus 32 plus 31 by 4. Whatever the value comes, it is Fm. And next sigma we have to find out. So for finding out sigma, there is one formula like sigma equal to root of summation of Fi minus Fm whole square by n minus 1. This is the formula. So how we calculate, how we substitute the values here? Here sigma equal to root of, there are 4 values. So some first Fi means first 25 minus Fm is what whatever value we have to calculate, mean value 20, and then 28 minus whatever Fm value we get, that plus, and 32 minus Fm square plus 31 minus Fm square. Okay, so we have to 31 minus Fm square by n minus 1. N is 4, 4 minus 1. If we calculate this value, we will get sigma. So after finding out Fm and sigma, we can substitute this value in the formula, like Fm equal to Fck plus 1.65 times of sigma. So FCK, they've asked for FCK. FCK equal to Fm minus 1.65 times of sigma. Fm is like average. If in these are individual characteristic strengths of the cubes 25, 28, 32, 31. We have to substitute here by 4 minus sigma. We already seen the formula root of summation of Fy minus Fm whole square by n minus 1. After like substituting this, we will get FCK value. In next class, let us discuss about load combinations. Thank you and please subscribe.